Okay, part A. We've got the centre of a circle and we've got a point on the circle. Right, the centre enables us to just write straight away x minus 2 all squared plus y minus 5 all squared is going to equal r squared. And we should know this from the general equation of a circle. Okay, so x minus a all squared plus y minus b all squared equals r squared. What we've got to do now is find the radius, or the radius squared. Well, the distance between the centre and the point minus 2, 3, if I do a little kind of sketch, minus 2, 3 and 2, 5. 2, 5 was the centre. Click, click. So, yeah, sorry. 2, 5 is the centre, and minus 2, 3 is the point P. Minus 2, 3. Okay, now, the line from P to the centre is the radius. So this line here is the radius, r. And to find the distance between 2 points, we use Pythagoras. So we take the difference of the x coordinates, so that's going to be 2 minus 2 squared, plus the difference in the y coordinates, 5 minus 3 squared. 4 squared, which is 16, plus 2 squared, which is 4. So r squared equals 20. And now we can just write down the equation for part A now. X minus 2 squared plus y minus 5 squared equals r squared, but we've just worked out using the point P on the circumference of the circle and the centre, 2, 5, both of which we're given. We've just found out that the radius squared is 20. So that's the equation. Right, now part B. The line L is a tangent to the circle at the point P. And if I draw that in, let me draw in the tangent. So at the point P, the tangent is the straight line which hits the circle, touches the circle just at one point. So it looks something like that. And that is what we call the tangent. Okay, and it tells us that Q lies on this line L, which is the tangent. So what that means is that if I draw a line down, this point here, point Q, is going to be vertically below the centre. So it's got an x value also of 2, and we need to find what the y value is. Right. Now the way to do this is to work out, or the various ways to do it. I think the best way is to work out the equation of the line L. And when you've got the equation of the line L, we just substitute in x equals 2, and that will enable us to find what k is. Now to do this, you've got to realise that the tangent makes a right angle with the radius from the centre to the point P. Okay, so what I can do is I can find, if I call the centre O, then if I find the gradient from O to P, that will be the change in y divided by the change in x. So it will be 3 minus 5 divided by minus 2 equals minus 2 over minus 4 equals 1/2. Now if the gradient from O to P, or from P to O, is a half, it doesn't matter actually whether we do it from O to P or from P to O. The important thing is that it's sloping up to the right. In other words, the gradient is positive. Remember that the gradient of the line, or the gradient of the tangent, I'll call it ML, has got to be minus 1 divided by that, which is like turning the fraction upside down and changing the sign. So the gradient is actually minus 2. Okay, so the gradient of the line L is minus 2, so we can quite easily find the whole equation of the line by doing y minus the the y value at p, which is 3, equals minus 2 brackets x minus the x value at p, which is minus 2. We then have y equals minus 2x minus 4 plus 3, or in other words, y equals minus 2x minus 1. And that's the equation of line L. What we can do now is we can now say that at Q x equals 2, therefore y equals minus 2 times 2 minus 1, which is minus 4 minus 1, which is minus 5. Therefore k equals minus 5, and we've done it.